All right, in this lesson, we're going to talk about the 5 types of chemical reactions. We got some pictures here. If on your reactant side, you have elements by themselves, so only one chemical symbol. This A represents any sort of element. This B is not specifically boron, it can be any sort of element. But if you have an element plus an element, which come together to form a compound, and truthfully, you could have more than 2 elements come together to form a compound. But if you have elements come together to form a compound, you end up with a reaction called a formation reaction. This is called a formation or a synthesis reaction. Elements coming together to form a compound. If you start with a compound, so if your reactant, which is only one reactant usually, if you start with a compound, usually just one reactant, and it breaks down into its elements, however many different types of elements it's made out of. This one, molecule AB, only has A and B, but it breaks down into its elements. This is called a decomposition. It's the opposite of a formation reaction. So in a formation reaction, we start with elements becoming a compound. In a decomposition, we start with a compound that breaks down into elements. These ones are pretty straightforward. Our next type of reaction is called a hydrocarbon combustion. This is called a hydrocarbon combustion. When you hear the word combustion, you might be thinking about a flame, fire, and you're right. Hydrocarbon combustions are actually pretty easy to identify because they always have the same reactant. There must be oxygen as a reactant. That's the big takeaway. And you always create the same products, carbon dioxide and water. It's always the same products, and oxygen is one of the reactants. The only thing that changes is this molecule here. In Science 10, it's going to be a combination of carbon and hydrogen, which is why it's called a hydrocarbon, hydrogen and carbon. Some form of carbon and hydrogen mixed together reacts with oxygen to form carbon dioxide and water. These products are always the same, and this reactant's always the same. Our last 2 types of reactions. If you have one compound, which reacts with one element to form a new element and a new compound, this is called a single replacement reaction. Because your individual element switched with one of the elements. It replaced a single element from your compound. So element C here switched with A. You replaced a single element. Compare that instead to this next one, where once again C and A are switching, but C in this sense is starting within a compound. So instead of a compound plus an element, you have a compound plus a compound, which forms 2 new compounds. C and A are still switching, but they both end up in compounds, not by themselves. This is called a double replacement. This table here shows you the same thing, just the words instead of a picture. Take a look at these reactions. Try and figure out what each one is and how you can tell. I'm going to just write a little key. You can check your answers against mine afterwards. But I'm going to say that F is for formation. I'm going to say D is for decomposition. going to say HC is for hydrocarbon combustion. SR is single replacement. And DR is double replacement. Those are the letters that I'm going to put in the blanks. Pause the video and try these questions out on your own, and then you can compare your answers against mine. All right, I'm going to work through these one by one. I have two compounds reacting together to form two new compounds. That's a double replacement. Once again, I have two compounds reacting together to form two new compounds. Also a double replacement. The big giveaway for number 3 that makes it not a single replacement. It might look like a single replacement, but two giveaways. First giveaway is that you end up with carbon dioxide and water, which is two different compounds, but you start with a compound plus an element. So it's not a single replacement. That's one thing that you can tell it's not a single replacement, because you end up with two compounds. But these three things, if you see oxygen as a reactant and carbon dioxide and water as products, this should be a dead giveaway that you have a hydrocarbon combustion. Compare that to 4, where you have an element on one side and a different element on the other side. This element is reacting with a compound. This is a single replacement. Number 5, I have two elements coming together. There's only one symbol in each of these, so that's a formation. Iron plus oxygen forming iron oxide, which is the opposite of number 6, where I have a compound breaking down into two elements. Number 7, two compounds at the start, two compounds on the end, double replacement. Number 8, an element by itself, reacting with a compound, forming a new compound, and an element by itself. That's a single replacement. Number 9, oxygen, carbon dioxide, and water has to be a hydrocarbon combustion. And number 10, one compound breaking down into elements. That is a decomposition. In the next lesson, we will work through balancing and identifying formation and decomposition reactions. And then after that, we'll move on to the other types of reactions.